Advising. We did talk about pre-advising Tuesday, right?
Yes, sir.
Okay. Anybody got any questions about pre-advising? Did y'all get to see your? Did you get to see your advisors or sign up? Yeah, no, Hubert. My advisor hates me, Hubert.
I saw mine.
What'd you say, Miss Abrams?
I saw my advisor.
Good. Did it go well?
Yes, it did.
Good. Anybody else got anything about courses or anything? Great. Well, that's a good thing because I just want to try to pass along the information to you, and if you got any questions, make sure you holler at me and let me know, because I try to, when it's pre-advising time, I do try to pass on as much information as I can to students so they can either continue or quit. So anyway, I try to encourage both. All right. Guess what? Start new material today. I'm going to Sharpies. I'm such a nerd. Okay. These 2 pens will last me probably 2 classes. We are going to start with quadratics. Now, I'm going to break up the test for Unit 2 a little bit. We're going to start with quadratics. Okay, so your next test will cover 3.1 through 3.4. And I can tell you right now, 80% of this test will be focused around completing the square. Okay. Now, in quadratics, you got the quadratic form of or the quadratic equation, which is ax squared plus bx plus c is equal to 0. And that is a parabola. Remember our family of graphs? This is a parabola. And your goal is to change that into f of x is equal to a times x plus h quantity squared plus k. This is your orientation. Whether it's compressed, whether it's stretched, whether it's concave up or concave down. This is your horizontal shift. It's always the opposite. If it's a positive, that means it's to the left. If it's a negative, it's to the right. And this is your vertical shift. Positive means up, negative means down. Your goal is to change. Now, by the time we get to the end of chapter 3.2, okay, 3.2, this right here is pretty much 3.1 through 3.2. All right, and you're going to be learning how to do this right here. And you can also apply this to f of x is equal to a times absolute value of x plus h plus k. You can apply it to f of x is equal to a times x plus h to the third power plus k. You can also apply it to f of x is equal to a sine theta plus k. So you can apply these 3 things right here to different functions using the parent graphs and horizontal shift, vertical shift, and compression or concave up, concave down. Here, same thing, orientation. You could have a vertical shift here, could be sine of x plus 3 plus k. You could have something like that, x plus h. So what I'm trying to show you is, we're not going to do all this, but if you learn this, you can apply it to all your family graphs. Okay, so your goal in 3.1, 3.2 is to learn what I teach you. Your goal is to not use factoring and quadratic formula to do what I'm trying to teach you to do with the completing the square. Because if you don't learn completing the square, then you're going to have a hard time in calculus. Okay? So, you are given a quadratic equation, and there are several ways that you've been taught to deal with this quadratic equation. The first is the reverse FOIL. Pronounce it however you would like. Okay. Second, we showed you the shortcuts back in Algebra 1 and 2. Shortcuts. 3, because you all went through high school, they drilled and beat the quadratic formula in your head. The quadratic formula, I hate to tell y'all, is only when you have decimals. 2.1x squared plus 3.2x minus 6.7. That's when you use the quadratic formula. And 4, completing the square. Now, why do I tell people to learn completing the square? Because completing the square is the only one you don't have to utilize a calculator with. Well, as far as quadratic formula, you have to rely on the calculator. So that's why it's used when you have decimals. Because nobody thinks in terms of decimals unless you're weird. Okay? So that's when you use the quadratic formula, because you have to use a calculator. All right? Completing the square uses elementary math and shortcuts 1 and 2. That's what completing the square uses. So if you tell me you can't use completing the square, you're basically telling me you can't do elementary math and you don't know shortcuts 1 and 2. Now, I want to see, and I want everybody to be truthful. How many of you have been exposed, meaning more than a week of doing it, completing the square? Raise your hand and leave it up. Okay, I don't know if y'all can see on the right side of the page, but so far only like 4 people out of 20 have raised their hands. Okay, you can take your hand down. How many of you have been exposed to the quadratic formula? Does anybody know why the hands are like all over the place? Somebody tell me why. Why do they teach the quadratic formula and not teach completing the square? You can take your hands down now. Anybody want to tell me? Because with the quadratic formula, they tell you to use what? Come on, say it. Starts with a C.
Calculator.
The calculator. Because they don't want to teach you the elementary math, because half of the teachers suck at it. That's why we got a lot of students that can't freaking make spell mom backwards when they get out of high school. All right. So with that being said, let's get started. Now, the way I show you completing the square is I show you 10 different levels, or a few different levels, 1 to 10. Okay, we're going to start with the easiest. Okay, how do you complete the square? Well, I'm going to show you the basics on how to complete the square. Number 1. Set equal to 0. Remember, when you find your y-intercept, you set x equal to 0. When you find your x-intercepts, you set what equal to 0? Y equal to 0. And that's basically what you're doing when you're solving an equation, a quadratic equation. You're finding the x-intercepts. That's what you're doing. The good thing about completing the square is that it gives you everything. Okay. So, Mr. Smith, I think it's Mr. Then I don't know if that's an okay. Do you need to take your hand down, or do you have a question? Okay, thank you. All right. And the reason I ask about London is because I've got a Landon Smith and I've got a London Smith.
Yeah, it's London, my bad.
Okay. So you're a London. I've got a Landon in another class.
Okay. Yeah, it's London.
Okay. I mean, it's a nice name. I just didn't know whether it was. Do you get that a lot with a name like London?
I did, like, especially in like elementary school and stuff, when Sweet Life of Zach and Cody was a thing, and it was like London. But
well,
yeah.
I'm gonna tell you something, Hubert. I got in more fights than I did, mistake for female or male. I got more fights in first, second, third grade because people make fun of my name. Being like named Sue. Any Johnny Cash fans out there? All right. So set equal to 0 is number 1. Number 2, move C. And I love when I say move C, students always ask, where do you move it? Well, where is C? It's usually on the left. So if it's on the left, where are you going to move it?
Right.
Thank you. So don't ask that question, please. All right. Now, this is the most important. 3. B over 2 squared and add to blanks. And I always forget the blanks. Sorry. Add blanks. Now, there's several different ways to teach completing the square. I choose the blank method because that's the easiest for students to grab a hold of. So just bear with me. If you learned it a different way, you might like the way I'm teaching it, or you may hate it. Okay? So 4. After you do number 3, you have shortcut number 1 or number 2 on the left. 5, you have the vertex, or f of x is equal to a times x plus h quantity squared plus k. And then 6, solve for x. Now, at the end, after you solve for x, you should be able to sketch a graph using the y-intercept using the x-intercepts and the vertex. You should also be able to find the domain, range, increasing and decreasing along with the line of symmetry. Now that's what we're going to do with these 10 problems. And by the time I get through with these 10 problems, you're going to be able to do 3.1 and 3.2 and part of 3.3. Now, there's one more step that we're going to add right in here when we get to level 5. So be sure to, we're going to add a step in here, right? In here, we're going to add a 2.5 later. So you might want to leave a space in there for a 2.5 when we get to level 5. Okay, so, and how do you get the y-intercept? Well, you plug in 0 for x. It's usually c. Okay, so you might need to make that note. C is usually going to be your y-intercept. It's always going to be your y-intercept. So you have that, and you don't even have to do any math. You wonder why my hands look so dirty? I was working on a tractor yesterday, and under the transmission of the tractor, that it gets real greasy and or nasty, and it takes a while for it to wear off, even if you wash your hands. I work on all our equipment, so when something goes wrong with our equipment, I have to fix it. So that's why my hands kind of look dirty sometimes. All right. I didn't want you to think I don't take a bath or anything. All right. So here we go. They'll start you off with a problem like this. F of x is equal to x squared plus 4x minus 7. And they'll say, find the solution, sketch the graph, what is the y-intercept, what are the x-intercepts, what is the vertex, put in vertex form, all of this stuff. I'm going to show you all of this. But this is about a level 1. It's very simple. This is the easiest of the levels. You can't factor it because 1 and 7 will only give you a 6 or an 8. You can't get a 4 from 1 times 7. So it's not factorable. It's not a shortcut. So we're going to do it. First thing you do is set equal to 0. X squared plus 4x minus 7 is equal to 0. Now, we also take our handy-dandy blue highlighter, because I never use it. We're going to highlight that -7 because that's the y-intercept. And we're going to go over here to the side and put y-intercept is 0, -7. You should do that at the beginning of the problem because when it's in this form, if you plug in 0 for x, you get 0 plus 0 minus 7. And that is your y-intercept. So write that down first. Set equal to 0, add your blanks, and move C. X squared plus 4x plus blank is equal to 7 plus blank. So far, not a lot of brain work. Now I'm going to write in red, and you know I don't write in red unless it's important. Hell, I can't even find it right now. Okay, here it is. I'm going to take B right here. B divided by 2 and square it. 4 divided by 2 and square it. 4 divided by 2 is 2. 2 squared is 4. I'm going to add that to the blanks. And that gives me shortcut number 1 on this side. So that gives me x plus 2 quantity squared is equal to 11. Now at this point, you can write this in intercept form. So here I'm going to say I can write this in intercept form, meaning f of x is equal to x plus 2 quantity squared minus 11. Now, I'm going to put this in a cloud because this is what they want in homework and test questions. Okay? They want f of x is equal to x plus 2 quantity squared minus 11. That's what they want in an answer when they say general form or intercept form. Now, you can get your vertex from here, or you can get your vertex from here. They'll be the same, but you can do them differently. If you get your vertex from here, you just take the opposite of both numbers. Take the opposite of both numbers. Opposite of both numbers. And that's going to be -2, comma, -11. If you get the vertex from here, you take the opposite of this one, and you just bring this one down. -2, -11. Now, I need you to make a note that you understand the difference between the two. If you take the vertex from this form right here, you just take the opposite of both. If you turn it into the intercept form, you take the opposite of the first one, the h, which is a horizontal shift, and you just bring this down. And this is what they asked for in the homework and the test. Now, if they just ask for the vertex, then you don't have to put it in this form. You can just get it from right here. Now, that's how you find the vertex. So our vertex, I'm going to do it in, let's see, orange. Our vertex is -2, -11. So now we got to solve for x. And I'm going to do another sheet of paper. So I need you to, well, I'll tell you what I'll do. I'll fold it. Things I do for y'all. Y'all are so spoiled. There you go. Dang-o, don't forget, I'm teaching Math 130 next semester. Dang-o, you better dang-o sign up for it. All right. So now I'm going to solve for x. So I rewrite my x squared, x plus 2 quantity squared is equal to 11. So far, we haven't done very much math. Only math we've done is right here. But high school juniors and seniors, they can't do completeness squares. We're just going to tell them how to use the calculator. They can't do basic math. All right. So I'm going to, if there was a number here, if there was a number right there, I would divide by that number, but since this is a 1, I'm going to divide by 1 on both sides. And that's going to give me x plus 2 quantity squared is equal to 11. And I'm going to take the square root of both sides. Now, at this point, I'm going to take my highlighter, and I'm going to take my yellow highlighter, and I'm going to highlight this thing right here. Now, this is very important. I'm going to write a bunch of stuff about that square root of 11 right there. What am I going to write about it? Well, in red, I'm going to write over here to the right-hand side, if they ask for exact in the directions, an exact answer, they want it in terms of radicals. If they ask for approximate, they want decimals. Okay, so if the directions of the homework or the test say type an exact answer separating with commas, then they want you to write it in terms of a radical. If it says approximate, then they want it in terms of a decimal, and they'll tell you what to round to. This number right here is also called, it used to be called the radicand. This is the radical. This is the radicand. It used to be called the radicand. But when it's this chapter, radicand, R-A-D-I-C-A-N-D, I believe. In all other maths, it's called the radicand. But when you start using it with completing the square, it's called the discriminant. And the discriminant tells you one of 3 things. If it's a square root of a positive, you have 2 x-intercepts, or 2 solutions. If it is the square root of a negative, you have no x-intercepts, meaning it does not cross the x-axis. And if you have the square root of 0, you have 1 x-intercept, meaning it sits on the x-axis. So when you take the square root of both sides right here, this guy right here tells you a lot. So make sure you make these notes about that square root of some number when you do this. Now, I'm going to write it in terms of a radical, and then I'm going to write it in terms of decimals because I'm going to sketch the graph, and I don't need radicals, I need decimals. So here we go. That's going to be x plus 2 is equal to positive or negative square root of 11. Is that positive and negative important? Yes or no? Well, I just put it in red, so that means yes, it is important. Why is it important? Because you're going to add the positive and the negative to get your x-intercepts. And x is equal to positive or negative square root of 11 minus 2. This is called the exact answer. Now, they may want it like this. Positive 11 minus 2, comma, negative square root of 11 minus 2. That right there is the way they want it in the homework and the test. So if I were you, I would take my green highlighter and I would highlight this right here because that's the way you're going to have to type it in with your answers. That's the way they want it typed in. Now, you may have one or two. Now, I'm talking in the 110 and the other classes that I teach. Now, this is a new course because it's in a new application. It's in my lab math. So they may be different. They may want it like this. I don't know until I see it. Okay. And of course, we know that the square root of 9 is equal to 3, and the square root of 16 is equal to 4. So between 3 and 4, 3.5, Hubert. That's right, class. So find the middle here. 9 to 16 is 7. Half of 7 is 3.5. Square root of 12.5 is 3.5. So I'm going to say that the square root of 11 is around 3.3. So that's going to be positive 3.3 minus 2 and negative 3.3 minus 2. 3.3 minus 2 is 1.3. And negative 3.3 minus 2 is negative 5.3. Somebody tell me what the square root of 11 is, please. That means I want y'all to type it in and tell me.
3.316. So I guess 32.
Okay, 3.316, 3.32, 3.3. Do I care if you're sketching a graph whether you take it to the 10,000th or not? No. And when you're sketching a graph, that's what you're doing. You're sketching a graph. So I'm going to go back to my original here. Oops, where's my original? Oh, here. My x-intercepts, I'm going to do them in green. I got one x-intercept of negative 5.3. And then the other intercept is 1.3. And that's my x-intercepts. So somebody tell me, what are we ready to do if we've got 4 or 5 points? What are we ready to do? You ready to sketch the graph, Hubert? Thank you, class. I appreciate the interaction. So we're going to sketch the graph. Y'all settle down, please. Y'all usually talk to me. What's up? What y'all in a pissy mood or what?
No, we're just trying to learn what you're saying because it's new.
Thank you, Miss Hollister. That's great. I'm not used to it.
So that explains why we're not saying anything, because we don't want to look dumb.
Well, there's a lot of people that don't know how to complete the square. And again, have we done anything that is rocket science? No, we haven't done anything. We've just added, subtracted, took the square root. We did use shortcut number 1, but that's it. But y'all can't handle this, so I'm just gonna make you. I'm gonna make you use a calculator. What?
The other difference is that we actually have a teacher who actually teaches us. Like,
No, I don't. I try to get you to quit.
No,
all right.
My mom had like this teacher in college. She was talking to me about it, who spoke fluent Chinese, and that was the only language that he spoke. So
I'm gonna tell you something. I had a teacher at Clemson, and that teacher, I'm not going to say where they were from, but they were the most insulting teacher I ever had. And all they did the whole time was talk about how stupid students were and how dumb Americans were. And I dropped, of course, because I wasn't going to listen to it. And they just better be glad that I took them before I went in the Marine Corps because I wouldn't have tolerated it after I got out of the Marine Corps. I wouldn't have tolerated it. But that was just, and the teacher sucked, so I dropped them. So I only was in there like a week. Anyway, I can't believe some of the stuff that I've heard teachers talk about. I can't believe it. They should be teaching. Anyway, all right, so our y-intercept is -7. There's our y-intercept. Our vertex is -2, -11. There's -7, 8, 9, 10, 11. And our green x-intercepts are 1.3 and 3, 4, 5, 6, 5.3. And what should all those points do if you've done everything correctly? They should. Look at there, ain't that pretty? And our domain, and unless you have a radical like the square root of x plus 2 or a radical 1 over x plus 6, unless you'd have two types of problems, your domain pretty much is going to be all real numbers or log. Okay? Any of these, if you have these, and we're going to get into that later, if you have a square root of x plus 2, 1 over x plus 6, log of something, x plus 2, if you have any of those, then the domain is going to be affected. But more than likely, in 3.1 and 3.2, if you get the domain wrong, you don't tell anybody, because that might put a sign on your neck, around your neck, that says, I don't know what I'm doing. Okay? I used to say something else, but that was offensive. It started with an S and ended with a D. Okay? But I can't say that because I might offend somebody. All right? So if you put all real numbers for every one of your domains in 3.1 and 3.2, chances are you're going to get it correct, unless the directions tell you to go from -2 to +4, then your domain is affected. But range, well, since we have arrowheads here and here, I'm going to do the domain. Let's do the domain in blue. The domain is all real numbers. That means all real numbers on the x-axis can be used in this function, because these two guys keep on going, and I'm exaggerating here, but they keep on going. So all x values are being used in this function. And it's not a radical, it's not a rational, and it's not a log. So range is your y-intercept, and we'll do that in orange. And these values, and of course, since I've got an arrowhead here and here, I'm going to use that arrowhead, which is called positive infinity. Okay, so I'm going from this y right here, which is the y of your vertex. So that's going to be -2 to infinity. Now I'm going to try something here. Which way do we leave? Which way do we leave? Which way do we read? Left to right. That's of course, unless you're from the Middle East. Assalamu. And there's our plane. We got a plane. Let's see if I can do this like I do at the, no, it's not going to let me. Shoot. Why can't I move that plane? Usually I can move the plane. Why can't I move it? That pisses me off. Okay, let's imagine that with this plane is coming from the left. And I'm going to use this plane, my cursor. What is happening to this function as I come from the left? What is happening? It's going down.
Yeah.
So I'm going to take my red pen. So it's going down. As I read this function from left to right, it's decreasing on this side.
Priority 1 message coming in on secure
Okay.
channel.
So you could write on this side, it's decreasing. Okay, remember we read from left to right. And on this side, and I'll use a dark green, what is the plane doing? It's increasing. And remember, this arrowhead down here is called negative infinity. And this arrowhead right here is called positive infinity. So we read from left to right, so I'm decreasing. From negative infinity to this x right here is -2. Yep. -2. And then I'm increasing from -2 to infinity. And my line of symmetry, and we'll do line of symmetry in some funky color like magenta. Line of symmetry always goes through the vertex. And we're going to talk about this in just a second. Line of symmetry, x is equal to -2. And let me erase that. Since I can't move my plane, might as well get rid of it. Now, I'm going to highlight one more color. And that color is going to be yellow. This one right here is the only one that's in reference to y. The rest of them are in x terms. This is in x terms. This is in x terms. This is in x terms. This one is the only one that's in the y term. Now, I'm just curious. How many of you, raise your hand, let me see, and leave it up. How many of you have seen this in entirety? In other words, from the beginning, when we did this, and we went all the way through and found our x-intercepts, and then sketched, and then did domain and range. How many of you, out of 20 people, how many of you have done all of that? Okay. 20 people, 5. And is that normal? Yes, unfortunately, that's normal. It is very rare that I get a whole class of students out of high school that know how to do this. Now, are you going to be is this a test question? No. This is about, let's see, 1, 2, 3, 4, 5, 6, about 8 test questions. Okay? But if you can do everything, you can handle anything I give you on 3.1 and 3.2. Capiche? Now, this is a level 1. You don't want to see a level 10. But hopefully in the next week or two, we'll get to level 10. Well, within the next week. All right. So let's do a level 2 or 3. Let's do a level 3. Mr. Justice, do you have a question or you just forgot to take your hand down? There you go. You're a winner. All right. So f of x, this is what will be given. F of x is equal to x squared plus 3x minus 12. Now, I don't want to do too big because we got small graph. So negative 5. Okay, I don't know if it's factorable or not. No, 1 times 5 will never give you a 3, so this is not factorable. You can't do a shortcut, so you're going to have to complete the square. Okay, so I'm going to set it equal. First of all, let's go over to the right. My y-intercept, 0, negative 5. Oops, sorry. I washed my hand like 3 times after I took a shower this morning, so y'all just ignore my dirty hands. All right, so x squared plus 3x plus blank is equal to 5 plus blank. Oh my gosh, what's going to happen now? We're going to have a fraction. So most of you should just go ahead and quit right now, right? Now I take B. I'm going to do this in an orange or another color. 3 divided by 2, square it. Oh my gosh, that's 9/4. Yep, might as well quit now because you can't do this. And that's going to give us shortcut number 1 on the left-hand side. X plus 3/2 quantity squared is equal to, well, of course, I'm going to change this to 20/4. And I shouldn't have to tell you why. And that'll give us 29/4. Now I can go over here and I can say my vertex is negative 3/2, comma, negative 29/4. Or I can rewrite this as f of x is equal to x plus 3/2 quantity squared minus 29/4. And I can take the opposite of this and just bring this down, and I get that. So this is what they asked for in the homework and the test when they asked for intercept form. And now I can solve. So I take the square root, I divide by 1. This is a 1. So I divide by 1 on both sides. Now, when we get to level 5 and 6, this is not going to be 1. It's going to be a 2. So it's going to make a difference. So I divide by 1 on both sides, and then I take the square root, and that's x plus 3/2 is equal to positive or negative square root of 29 over 2, and that's going to be x is equal to positive or negative square root of 29 minus 3 over 2. So the way that they want this in the homework and test is going to be the square root of 29 minus 3 over 2, comma, negative square root of 29 minus 3 over 2. Okay, so depending on what book you have or what homework you're doing or what test you're doing, it can be written as this way or it can be written this way. Now I'm going to change 29. Let's see. The square root of 36 is 6. The square root of 25 is 5. Halfway is 5.5. So halfway between 20 is 11. 5 is square root of 30. So I'm going to say it's 5.4. So positive or negative, 5.4 minus 3 over 2. 5.4 minus 3 over 2. Negative 5.4 minus 3 over 2. 5.4 minus 3 is 1.4. And what's half of $1.40? 70 cents, Hubert. That's right, class. And negative 8.4, what's half of $8.40? And there's our two x-intercepts to graph with. Now, Miss Hollister, I'm going to pick on you because you said you're one of those people that have seen this before. Are you overwhelmed, or is it just basic math, or what?
Oh no, I get it now that you're going over it. The way that you're teaching it's easier than my last teacher taught it.
Good. Now, your last teacher, was that a college class, or
Yeah.
was that Algebra 1 and 2?
It was a college class.
What college class was it?
Whichever class was before this, so
102?
Yes, I think so.
How about you, Mr. Abdallah? I saw your hand go up.
Yeah, I actually just kind of have a question. I kind of got confused.
What's your question?
So why? Okay, you know what? Now that I'm looking at it, maybe I do get it. Okay, I just got confused on why it became 3 over 2. You know, I understood that the process to get to 9/4, right? To get to 9/4.
Yeah, you have to divide b divided by 2.
I just didn't know that it would carry over from that. Like it would still be in 3 over 2.
Yeah. Now, why didn't I change it to why didn't I change it to a decimal? Can anybody answer that? Because if you change it to a decimal, you got to start using what?
Calculator.
You got to start using the calculator. And I know y'all are conditioned to use that calculator, and that's why we got students that can't make change and can't spell mom backwards. All right, so now I'm going to take all this information and I'm going to put it on the graph. So I want you to do that right now. I'm going to give you a minute. I'll highlight what you need to graph. You need to highlight, there's your y-intercept, there's your vertex, and here are your x-intercepts. So you need to highlight those. You know it's going up because it's concave up because it's positive. And we're going to get to that here in just a second. Okay, since this is a positive x squared, that means it's concave up. And we're going to get to that eventually. Okay, so I'm going to take my handy dandy I'm going to try to draw it. I'm going to use my straight edge here.
Priority 1 message coming in on secured channel.
And my y-intercept is 0, -5. My vertex is -1.5. And -4, we're going there 7, 7.25. Negative, let's see, 1, 2, 3, 4, 5, 6, 7. So somewhere right in there. Oops, right in here. And my x-intercepts are 1, 2, 3.7 is right in there, and 4, 5. So it looks like to me we got some kind of graph that looks like this. Of course, it needs to be a little bit more rounded. There we go. And of course, this is positive infinity. This is negative infinity. This is negative infinity. And this is positive infinity. And we have arrows on all these functions, because unless you, I'll tell you when you wouldn't have an arrow. If I said in the directions, x is between -5 and +5. If I said something like that in the directions, if I said x is between -5 and +5, if I said something like that in the directions, then these arrows, all these arrows would go away, because this is the only x's you have, -5 to +5. So unless it says something like that, most of the time you're going to have arrows. All right, so the domain is all real numbers. I told you don't really have to think about that unless something like that is in the directions. Domain is all real numbers. Range, remember, range is the only one that's in the y, so direction. So that would be the vertex, which is -29/4 to positive infinity. And then decreasing from negative infinity to x is, that's the line of symmetry, 3/2. And then increasing from 3/2 to infinity. Line of symmetry is x is equal to -3/2. I'm really surprised that you had completing the square in 102. Usually they used to not teach completing the square. But how is it? How is it so far? Are we doing good? We hit about, this is a level 3 or 4. Okay, what's the difference? Well, the only difference is in the first problem, in level 1, 2, let me get the original. Where's the original? There it is. In the original, that is a divisible number by 2. B is divisible by 2. A level 3, 4, B is not divisible by 2. And one of the worst things you could do is change it into a decimal. Because if you change it into a decimal, you're tying your hands behind your back, because you can't do simple math with decimals, especially multiplication and division. Okay? With leaving it as a fraction, you just take 3/2, square it, and you got 9/4. Now, if you can't do that math right there, then we got to have prayer meeting after class. because everybody should be able to raise 3 to the second power and 2 to the second power. It's a whole lot better than trying to do 1.5 to the second power. Then you have to depend on a calculator. We feel good? Hopefully everybody should feel good. Of course, y'all not going to say anything, so that leaves your teacher in the dark.
Yes, Hubert, we feel great.
There you go, Miss Hollister. Miss Hollister's getting pissed at me. She's turning into a wife. Okay. Yeah. We feel good. Yeah. Go on. All right. F of x is equal to, unfortunately, Miss Hollister, it would be best if it came from other people besides you and Mr. Abdallah. Okay. But anyway, I'm not going to complain. All right, here we go. Negative x squared plus 3x plus 4. And of course, we have the negative out front. That means that it's going downward, and we'll get into that in just a second. So the first thing you do is set it equal to 0. And negative x squared plus 3x plus blank is equal to negative 4 plus blank. Now, I cannot use completing the square unless this is a positive 1. Okay, and I'm going to put that in red so you'll remember it. In order to complete the square, A has to equal a positive 1. If A is not positive 1, then you have to factor it out. If A is not equal to 1, you have to factor out. And my hand is frozen. There it goes.
You have a work email.
So I've got to factor out a negative 1. Okay, so I'm going to factor out a negative 1. I'm going to do that in, I don't know, purple. This purple right here, or lavender. I'm going to factor out a negative 1. If I factor out a negative 1, that's going to give me x squared minus 3x, plus blank is equal to negative 4 plus blank. And if I factor out if I factor out anything, I have to multiply it by this right side blank. So we need to write that in red. Whatever factored out, multiply by right side blank. If I factor out a negative 2, then I got to multiply this right side blank by negative 2. If I factor out a 25, then I need to multiply this right side blank by 25. Now, why? Well, there's different ways of doing completing the square. One way to do completing the square is to do it all on the left-hand side of the equal sign. That's why this is multiplied by the negative 1. I'm not going to show you because it would confuse you. And the left side, let me ask Miss Hollister, when you were taught completing the square 102, were you taught to do it all on the left-hand side?
Yes.
And that's why it was confusing. So it's either I confuse you with the left-hand side completing the square, or tell you to just do this and trust me, and I hope you would do the latter. Okay? So I'm going to take the highlighter and I'm going to highlight that in yellow. Since I factored out a -1 here, I've got to multiply it by this right side blank right there. And you will do that 100% of the time when you factor out something. So now I've got to take 3 divided by 2. It's just like the previous problem. 3 divided by 2, square it. Oops, I need to do that in another color. Ooh, I hate orange and black. That's why I don't like Halloween. Ugh. 3 divided by 2 is 3/2, and square it is 9/4. So 9/4 goes there. 9/4 goes there. And that's going to leave us with -1, shortcut number 2, and that's going to be -9/4. So this is going to turn into -16/4 minus 9/4, which is -25/4. And now this is our setup for a vertex, or vertex form, and a y-intercept. We already got our y-intercept. Y-intercept is 0, 4. And our vertex is 3/2, comma, 25/4. And f of x is equal to -1 times x minus 3/2, quantity squared, plus 25/4. And of course, you just need to know that just so you know how to type it in to the homework and test. Now let's finish it. And I'm going to divide by -1. That leaves us with x minus 3/2 is equal to 25/4. X minus 3/2 is equal to positive or -5/2. And x is equal to positive or -5 plus 3/2. And 5 plus 3 is 8. 8 divided by 2 is 4, so that's 1 x-intercept. And -5 plus 3 is -2. -2/2 is -1. So now I want everybody to graph it. We've got a -1, 0 as 1 x-intercept, and 4, 0 as the other x-intercept.
Hubert, our test is due Sunday, right? Not today. I thought it was today.
Yeah, you're welcome.
Okay, thank you. I was just making sure that I got that right.
Yep. I wondered if somebody was going to bring that up.
Wait, you moved it?
Yeah.
Oh my goodness. I was just looking at it last night and it said today at 11:59. I guess.
Yeah, I moved it right before class. The reason I moved it is whenever I am going over new material like on a Friday or a
Yeah.
Thursday, I say, you know, might as well give them the weekend to finish up what we just finished. So I'll give you the weekend to finish it up. But that means I'm not going to go over any questions.
Yeah.
Tuesday when we meet, we're going to continue on with what we're doing. So
Well, thank you. So
you're
sweet.
welcome.
I really appreciate it.
Okay, so we're going to graph this one. And we've got a 4, 1, 2, 3, 4. There's our y-intercept. 1.5. It's right there. And 4 will go into 25 6 times. That's going to be 6. And wait a minute. 1, 2, 3, 4, 5, 6. Okay. And -1 and 0. And 4 and 0. Oh my gosh. What is this parabola doing? It's concave down. The reason it's concave down is because A is a negative. Because A is negative. Okay, that's why it's concave down, because this guy is negative right here. So you can circle this concave down. When you see that negative come out, that means that your answer is going to be concave down. So domain is all real numbers. Range is equal to -infinity to whatever number that is. I think it's 25 fourths. A lot of students ask me, Hubert, why'd you start at the bottom? Because I don't walk around with my nose in the air. That's why. Most people, when they walk around, you know, like walking down the sidewalk, they usually tend to look at the ground like 30, 40 feet in front of them. And then if something happens, they look up. Whereas some people walk around with their nose in the air all the time. And I really don't want to be associated with somebody that walks around with their nose in the air all the time. Okay, so the range, that's why I start from the bottom. Okay, and increasing, since we read from left to right, we're increasing from -infinity to 1.5. X is equal to 3/2. That's our line of symmetry. 3/2. Oops. And that gets a bracket. And decreasing from 3/2 to infinity. Now, that one is a level, what did I say it was, a 4, 5, maybe a 4. That's 3 problems we did. We did one where B is divisible by 2. We did one where B is not divisible by 2. And then we did one where A is negative and we have to factor it out. And that's a good stopping point. Now, I do not suggest, now you can, if you want to, work on homework 3.1 and 3.2, but I'm not going to technically assign 3.1 and 3.2 until probably the end of Tuesday when I finish completing the square. And I can promise you when you finish completing the square, when I finish it with you Monday or Tuesday, you should be able to do most of 3.1, 3.2, and some of 3.3. So if you want to go ahead and get started on it, you can if you don't have anything else to do this weekend, like chapter 2 stuff or whatever chapter we were on and test. If you don't have any of that to do, then you might want to, you know, play around with it, read a little bit, try some problems. If you don't want to, that's fine, because I'm not going to expect that you do that until Tuesday. But you can do what you want, okay? Let me look at the roll right quick. And somebody chatted something. I'm sorry I missed it. Okay. You asked a great question, Miss Babineau. I'm going to show you one thing right quick, and then we'll do the, I can't talk. We'll do the attendance. When Michael Jordan leaves the basketball court and he jumps up to do a layup and dunk it, not a layup, but dunk it, he basically does this. Let's say this is the goalpost. Everybody with me? And he goes up to this point right here, and that's called the vertex. I don't care if you're throwing a baseball in the air or a 10-pound ball or a cannonball or a basketball, or if you're flying, if you're jumping and you jump to dunk a basketball and come down. Everybody at this point for a millisecond is what? What can you tell me for that point is happening? You're actually flying, because you're not going up and you're not going what? Down. For 1 millisecond of time, you're basically not going up or down. And that's why when you're doing increasing and decreasing values, you don't get brackets at the vertex, because you're neither going up or down for a millisecond. Does that help, Ms. Babineau? So, okay. So at the vertex, you always have parentheses, because you're neither going up or down at the vertex.
I was going to say that.
Say again?
What you did just helps.
Thanks. Okay. So let me shut down the recording and go over right quick. I think